You're great. Yeah, it does go with that. We're going to talk about that in a second. Okay, you'll notice you got big words here. And I want you mostly to have heard them in case some of you probably have some college stats in your future, and you'll see probability in a college stat class. You're looking to be a business major, you're looking at 2 semesters of college stats. And several other majors do at least require 1 semester. So in this case, you got mutually inclusive events, big words for a very simple concept. If something's mutual, we both agree. If you mutually agree to something, we both agree. So mutually is both. Inclusive means included. So both are included in the event. What we just did up here, we had aces and black cards. That's mutually inclusive because they both had some things in common. They share common events. There's something in common between the two. In this case, the fact that there were black aces. They got counted in both groups. So what we did then is we subtracted out the duplication. We subtracted out the 2 out of 52. Whereas you can also have mutually exclusive events. What does it mean to exclude something?
Take them out of there.
Yeah, throw it out, keep it away. So in that case, the 2 events have nothing in common. They share no common items inside that. Okay. If it's mutually exclusive, are you going to have to worry about subtracting anything? No, you won't. If it's something or something and they have nothing in common, you'll just add the 2 and be done. But it's really, really easy to forget to check for those duplicates, those ones that overlap. Okay, so I got another card problem for you down here. I want the probability, this time is a little different. It's the same thing as what we did up above, except I'm now picking 2 cards. I want the probability that I will get 2 aces or I will get 2 black cards. Can I do it up here? I just did single little fractions that I added. Now I'm picking more. That was picking 1 item up there. Now I'm picking 2. So now you have to not decide, is it combinations or is it those little individual fractions? Yeah, decisions is the problem with this. So go through the combinations list. Do you have any replacement?
Nope.
Does it say you're putting the cards back in? Does it say you have to pick an order? Nope. Is it dependent? After you pick one, it'll change your chances on the next one. Yeah. So all three rules of combinations were there. So it's a combination problem. These kind will typically be combination problems. You should expect them. So okay, I got to pick 2 aces this time. How many aces are there?
4.
There are 4 aces. How many are you going to pick though?
2.
I need to know how many groups of 2 different aces can I get? 4C2 will turn out to be 6. There's 6 different pairings of aces you can get. Cody, look alive.
That's 3.
That was a 2. That's smeared. Okay. What does OR say?
What?
Add. Okay, now I got to pick 2 black cards. How many black cards were there? 26. How many are you picking? 2. Okay. Are there possible overlaps? Did you count some here that were in the aces that were also in the black cards? Okay. So when you're picking more than one, though, when you subtract out the duplications, you have to subtract it out using a combination. You got to do it all the way through. So how many possible black aces were there? 2. And how many of them could you have picked? 2. Yeah. So it's just 1. You're going to be subtracting 1, I guess. Because there'd only be 1 pair you could get that did that. Okay. Grand total, how many total cards did you have? And how many cards did you actually pick?
4.
Draw 2 cards. You wanted 2 aces, you wanted 2 blacks, but you're only picking 2. The whole time you were only picking 2 cards, so it stays a 2. And if you calculate that lovely one, you will get 55 over 221. Or... That's about a 24.9, so right about a 25% chance that you would get 2 aces or 2 black cards. Which kind of sounds about right. Makes sense. Okay, you think you have we're gonna do another mutual inclusive exercise. I hope you all are gonna work better today than we worked this morning. The the numbers in their classes did not work well for my next problem, because I was using their class as the basis for my problem, and it crashed and burned. So, we're going to fix this. In this room, how many, I actually have to have seniors now, too. Some years I have seniors, some years I don't. Okay, so I have 1, 2, 3 seniors? 4 seniors, that's right, I have 4 seniors. Okay, what's the breakdown male-female on seniors? Okay, I got 2 males, 2 females. Juniors were, anybody remember from the other day? 1, 2, 3, 4, 5. And what's the male-female breakdown?
2 males, 2 females.
2 males. And then lastly, the sophomores. Be nice. 8. 4 and 4. Wow. Okay. You all just made my life easier. Thank you. This works. My problem actually works. This morning is heavily lopsided males and all junior males, and so it was kind of messed up my problem. Somewhere. All right, so 3 of you lucky people get to be selected for my I Love Math committee.
Are you being serious?
Actually, I often thought about having a math club.
I bet you I've got a chess club. Except for the fact that nobody would. No, I bet you a couple people would. Yeah, you probably get like 2 or 3 people.
We have enough trouble getting the meetings scheduled that we have already, let alone trying to cram more meetings. Okay, you're going to look at this and you're going to see what word is going to clue you in here. I want the top one. Or. You're seeing 3 juniors or 3 females. Okay, so we know we're going to add. That also means that there could be overlaps, duplications. Could there be juniors who are also females? Yeah, we have potential overlaps here. So therefore, we are going to have to subtract our duplicate. We could do that one, but I'm going to do this one first. Okay, so how do I get my 3 juniors?
5.
There are 5 juniors to pick from, and I need 3, because this is going to find me out how many groups of 3 juniors can I pick. This is just telling me how many different groups of 3 are there. Or is going to be what? Okay. Now I need to get 3 females. Any age, they can be 3 females.
Bye, Lana. You'll hear me on this video.
5.
Bye.
So now there are 9 females in the room, and we're picking how many of them? 3. Then what are we subtracting? If we think there's overlaps between the 2 groups, how many junior females are there? 3. And how many could I pick? 3. The most I could pick is 3. So that's actually subtracting 1 then, yes. Grand total. How many of you in this room? 17. And how many people were we actually picking? We're only picking 3. It says you're selecting 3. And in this case, I don't know this answer. Okay, that's going to be 10. Less than, that one doesn't go down as nice. 3, 4. I think that's 84. Oh wow, and I'll never do 17.3. Whoa, that's too big. Well, why aren't you going there? Well, I keep screwing mine up too here. All right, 680. So that would be 94 minus 1. That'd be 93 out of 680. Or will it go? That's reduced. That's as reduced as it gets. It goes down to about 0.136, so it's about a 13.6% chance that we get 3 juniors or 3 females. Okay, you're all with me so far? All right, here's the last one. This is probably my #1 most missed question on this next test.
It's because it says,
10 plus 84 would be 94, minus 1 would be 93. Okay, well let me make sure, maybe I was doing some of them in my head, so maybe I may have gotten it wrong. Let me, that's 10. 84. I got the same numbers again.
no.
Okay. All right. Why is the last one going to be the most missed? Well, yeah, at least. What does it mean when it says it's got to have at least 3 males? Okay, yeah. But remember, you're picking 5 students. So at least 3 males means I could get 3 males. And thank you. And he said the key words. I could have 3 males and 2 females. If it says you're picking 5, you got to have 5 people here. The best thing you can do on these at least or at most problems, list out what your possible situations are. Then go worry about doing the numbers. Because I could have, 4 males and 1 female, or I could have all 5 of them be males. And that's what you have to realize. Anything that's at least or at most, you need to list out all the possible things that could happen, because there's going to be more than one. Now, yes, it is. Thanks, Blake. Did you catch that question? Blake said, is it times plus times? Yeah. 3 males and 2 females, I'm going to multiply that. That's an and. I'm going to pick them with combinations. Okay, so how many males were in this group?
3.
In this class? 4, 2, 4, 8. We had 8 males and we're picking, we only wanted 3. Now I need 2 females. And there are 9 females in the room.
You're picking 2.
I'm picking 2, yes. Then it says or. Plus. Okay, now I got to pick guys again. There's still 8 in the room, but this time I'm saying, well, maybe I picked 4 of them. And says I multiply, and I have to have 9C1. Or, again, is another plus. Now I got to pick all males. So how many males are there? 8, and I'm going to pick 5 of them. Now, is this going to be a doozy to type in your calculator? Yeah. And then last but not least, grand total on the bottom. How many total people? And then think about it. How many people are we actually picking? Pick 5 students. Yeah, that's going to be fun. You're right. Yeah, I'll actually be straight. I'm not thrilled with how these calculators punch combinations in. I can do it faster on here.
Do we have those for this next one?
For one little part, probably not worth it.
What model is that, Miss Meyer?
This is just an 84.
Oh, okay. I didn't know those could...
So since you all are a different class,
Will they always be multiply, add, or something?
in this type of situation, yeah, because you'll have these and these, you'll have a group that'll be and. Or your next possibility is this group, they'll have an and in it.
193, 442.
I think I just wanted you to, I only wanted you to just list out your possibilities.
193 over 442.
Okay, thank you. 193 over 442.
Yep. 4.436.
0.436. Okay. So, if I pick 5 students, there's a 43.6% chance that I'm going to get at least 3 males or At least 3 males on my committee, yeah. Now, on all of these, darn, I didn't do this back there. On any one of these problems I've done all of today, if I had said find the odds, would you have done anything differently?
You would have started with that, and then
You would have done every one of these the same. You'd have found the probability, and then if I asked for odds at the end, boogers. At the end, you would calculate the odds off of it.